So we have here a math example, and my goal with this and the next example is to show you where omega equals square root of g over L comes from based on an energy analysis. It turns out to arrive at that result, you, just like the mass on a spring, have some choices. You could do a force-based analysis, or you can do an energy-based analysis. The force-based analysis gets to be rather complicated, and it turns out the energy analysis has its complications as well. So I've decided to go with the energy analysis nevertheless because I think it's slightly less complicated, but we need this math result here to get there, and this is a result that is more easily derived from calculus, but in this example I'm going to show you a way of getting there that doesn't really rely on calculus. That being said, this is information that you're definitely not really responsible for in this class. The way that I'm doing this here is I'm going to say cosine of x is equal to the square root of 1 minus sine squared x. I think we can all recognize that that's based on a Pythagorean identity. And we showed earlier that sine of x when x is small is equal to just x. So I'm arguing, well, this is approximately equal to the square root of 1 minus x squared. And so wouldn't it be neat if I could do something with that to make it into the result that I want here? And it turns out there is a way to do that using the binomial approximation. It says 1 minus x to the n. And so, like, as an example there, if I had, say, 1 minus x squared, we all know that that would be equal to 1 minus 2x plus x squared. But if x is really, really small, then this term right here can be regarded as being highly negligible. So we can just like say, let's ignore that one. We're just going to cross that one off. And that would leave 1 minus 2x. And this 2 is just the same as this exponent. If you did, for example, 1 minus x cubed, and this may be the limit of what I can do here in terms of like doing all the algebra on this, but I think this one would be 1 minus 3x plus 3x squared minus x cubed. Okay, that's as much algebra as I want to do today. And there's a similar argument, though, that all these higher terms up here, since they involve higher powers of x, if x is really, really small, I can just say those are negligible, and we're just going to cross them all away. And then once again, we have this 3, which comes from this exponent. So in the formula here on the slide, it's saying, couldn't we just approximate 1 minus x raised to some power as 1 minus that power times x? Well, if you do a square root of something, a square root is equal to a power of a half. So what if n is equal to a half? And then instead of x in here, I have x squared in here. If it was 1 minus x square root, I just get 1 minus x over 2. But since it's x squared, I get 1 minus x squared over 2. And that was actually, I kind of got here by starting with the original cosine. And so my argument is that therefore cosine is approximately equal to that.